I did a lot of reading in Nehari this week. I completed the rest of chapter 3, and then chapter 4 is very brief. But chapter 4 was very insightful. I mean, I really enjoyed chapter 3, which is really things that I already learned in Sept and Snyder, so it was really very much a repeat. But yeah, definitely. So right now I'm going to start reading chapter 5, and I decided not to do any problems in chapter 3 and 4 just because I already did problems like these in Sept and Snyder, and I want to make sure that I make progress enough so I can jump over and start my Baby Rudin project full steam ahead. And so, as a matter of fact, 5 minutes before making this video, I had decided to stop reading Nehari altogether and just cut bait. And I don't know if you know what the term means. I'm going to put it in the description of the video, what cut bait means. But just, okay, fine. I got what I wanted out of chapter 1. I learned some about harmonic functions, and it's sort of like the missing chapter from Sept and Snyder. But I have several reasons why this book is giving me trouble. Number one, I'm missing some prerequisites. I think this would have been a much better book to take with another conformal mapping book that had more examples, was more like a baby conformal mapping book. And also after I do Fourier analysis, and as I'm in the middle of a second pass for complex analysis. But even then, this book, one of the things that it's really helped is it's got so many callbacks to authors that I've ended up reading, like, I think 10, 15, 20 pages in authors by now, just because it pairs up so well. And so actually, and I'm going to talk about the reading itself for Nehari, but the main thing really that has taught me is that these 4 books really go well together. They really do. Because I am reading Bardo and Sherbert for the Baby Rudin Project. I'm really enjoying it, and I'll make videos about that next week, or maybe tomorrow, I'm not sure. But these actually, as a matter of fact, because they're both blue, sometimes I'll be reading on one, and I'll be like, oh, wait a minute, I really wanted to go to read this other one, not this one. And then also Churchill. So really, yes, I almost thought, okay, not only am I reading these 2, I'm going to start reading these 2, but I was like, no, that's too much. That's like 20 books at the same time. That's crazy. I can only do 1. And so, yes, I decided I'm not going to do that. I'm not going to read authors, page by page, or Churchill page by page, which I really want to do someday. But because I will be working on mathematical analysis for the Baby Rudin project, I will be using authors and I will be using Churchill as I read Baby Rudin. But anyways, and so what I am going to do, instead of stopping reading Nehari, which I think would have been a crime against conformal mapping and great books, I'm just going to reprioritize. So these books for the Baby Rudin project are going to be number 1. These are the books that I'm going to read the most. I also have extra time at the end of the year, so I can do this. And then Nehari, I'm going to read once a week. Once a week I'm going to read some. And so it'll take me the rest of the year probably to read the rest of the book. But the book is really well written. I'm learning, and that's good. So yeah, so then if I go and show my progress in notes, I did try additional problems in chapter 2. And yeah, tried additional problems, helped with my arithmetic, or I would say algebra, my algebra for complex numbers. It helped. Figured out the cosine n theta plus I sine n theta expansion. So that's good. Some problems are just beyond me. Yeah, the book has very few problems, and I find that there are some problems that take me like 5 minutes to do. And then there are some problems where I'm like, I'm not sure I want to spend 5 days working on this problem at this point for a first pass of complex analysis. So yeah, I read about Heron's formula, very interesting. And so yeah, I could come up with an answer for what is the area of an arbitrary triangle in complex space. But when I look at the formula they have in the book, it's nothing like what I did, so I know I'm not there at all. And then when I tried, they gave Nehari gives me like 1 plus alpha, 1 minus alpha, absolute value is equal to 1. Well, alpha equals 0 will do it, so I think that's the answer. But then in the one that's 1 plus alpha, 1 minus alpha is equal to 2, I worked on it pretty hard, and I think I came up with something that's reasonable. At least I came up with one value. And so the circle, a squared plus b squared, with radius square root of 10a over 3 minus 1 solves the equation. And sure enough, when you try alpha is equal to 3, 1 plus 4 divided by 1 minus 3, 1 plus 3 divided by 1 minus 3 is 4 over minus 2 absolute value, so it's 2. So there's at least one solution. All right, so I kept going. Couldn't figure out this formula for multiplying sequences. I just couldn't. And then, solve continuity. Continuity does map out from reals to complex, so I think I did that okay. Same here. Show why specific functions do not meet the Cauchy-Riemann equations. Show why in some cases they do. I think I kind of got this right. The square root of value, the absolute value of f of z. I'm not sure. I wish the book had answers. That's the thing that really gets me. The determinant of the Jacobian, I think I got that right. And then after that, I was like, all right, I'm gonna read. And I thought of doing problems, but then I said, I already did problems for this content in Sept and Snyder, and for past number 1, I'm satisfied. But I really like the way Nehari explains the same concept that I already read. It felt really good to review all of that content in Nehari and take notes, see a slightly different take on some of the concepts, and see even like some additional things that he does that were not done in Sept and Snyder, and I enjoyed them. And so I think that was good. So Cauchy's theorem, this whole thing about multiply connected domains, the concepts of single-valued, multi-valued, then of course contour integration, which already I did in Sept and Snyder, some good examples. It does not hurt at all for me to read this material. Cauchy's formula, then how you can differentiate within, inside the integral, and then come up with a general formula with some of the additional wrinkles like Morera's theorem. Kill the mosquito, that's my blood. As I was, the mosquito just stood there and I was like, what are you doing? Boom. And sure enough, there's the, my blood from squash mosquito. There it is. Taylor series expansion. Then at some point, analytic continuation, which of course I think I already mentioned last time, how I really took my time and read it very carefully. It is very well explained. Took me a long time to go through just 2 pages of Nehari, but I believe it was worth it. Then permanence, the principle of permanence for analytic continuations. Then the monodromy theorem, which is discussed in Sept and Snyder. Then Lorentz series, which I did already a deep dive when I was studying Sept and Snyder, so I'm very happy about that. Power series, which I could always get better at because they always kick me hard. So the whole Lorentz series, content, rational functions, expansions of rational functions, Louisville's theorem, then the fundamental theorem of algebra. This is all also done in Sept and Snyder, but it's great to see it again. The maximum principle, of course, which I made a video about, and I said at the time that I had not read this yet, so I read it. Then the residue theorem, with an example, very interesting example. So Sept and Snyder, Nehari does have examples. I just wish he had more baby problems. That's all. This I don't understand this step. I missed it. I gotta I think I need a course on combinatorics in my future, just to understand all those tricks that you need for these formulas. Then the argument principle. Yeah. Leading to Rouché's theorem, the whole wrapping around the dog around the tree that is explained in Sept and Snyder, but here with a different formula. I sort of understood it, but I kept going back to Sept and Snyder, and I'm like, okay, this is different. This is different, the way Nehari does it. Back to the maximum principle using Rouché's theorem. Yeah, and then when I hit chapter 4, I love chapter 4, even though it was brief, because it really, that's the one where I was like, man, I gotta read Alfred someday. The callbacks to it were great. The whole thing about a normal family, equi-continuity or equi-continuity. And the tie-in, of course, to the Bolzano-Weierstrass theorem. So I went back into Wade, wrote it down how it's written in Wade, then how it's written in Alfers. So I really like that the same theorem, of course, is found in a complex analysis book and a real analysis book. Yep, normal families of analytic functions. And I also read some of this content over in Alfers. Montel's theorem and the proof of Montel's theorem. It's kind of interesting that when Nehari starts does the proof for Montel's theorem, at some point he needs to do a diagonal, one of these diagonal trackings to say that something is countably infinite. And I had just read this in Bardo and Sherbert, because I am reading Bardo and Sherbert, the early chapters. Yeah, then extremo problems. And that was the end of that. So I've read up to chapter 4, and no, I'm not quitting Nehari. I am just flipping the priority, and so I will focus beginning on for the next video, which I think it'll either be later tomorrow. I'm not sure. If not next week, then it'll be the Baby Rudin Project, and then every now and then I'll post something about Nehari, because I am curious to get to the end of the book, even if I don't do that many problems.